Welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week we're discussing the major CrowdStrike related incident that impacted services around the globe, as well as the similarly timed but separate regional Azure outage and other recent outages and disruptions of note. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On with the show, and we start with that CrowdStrike incident on July the 19th, in which the company pushed out an update for its security software that had a wide reach and impact for many companies, including airlines, banks, and hospitals. I asked Mike to detail exactly what happened.
Just as an opening to this, I actually want to say that this wasn't a network-centric problem. What I mean by that is it actually manifests itself in terms of looking like a network problem, i.e. people appeared to not be able to connect to certain services that were running. But it was actually not a connectivity problem, but a problem with the end systems themselves. So what actually happened on Friday, July the 19th at 4:09 UTC, and as part of regular operations, we're told by CrowdStrike, they released a content configuration update for the Windows sensor. And this was to actually gather telemetry on possible threat techniques. Once this update was actually received onto these systems themselves, so these Windows host systems, it actually triggered a logic error. Now, what this logic error did was actually sent the machine to a crash state.
Not only did these systems crash, but they entered a boot loop where the systems kept returning to the same error message.
Now, when these systems entered into this boot loop, what the users were actually seeing was the blue screen of death, so the BSOD. So what that is then is it goes into this recovery mode, and you see sort of the blue screen with a smiley face. This indicates that this system's in a crash state. This update was actually sent out to anyone that's had that Falcon sensor, but it only went to the Windows host machines. As we get into this, what we'll see is the fact this was impacting the Windows hosts themselves might have actually given the impression it was actually sort of a Microsoft-related issue, where in fact it was just that it was actually on these systems themselves.
Can you explain why updates to security software such as CrowdStrike differ from regular Windows application updates?
So let's consider the nature of this system update. Now, these are used to sort of protect against cyber attacks. So these updates really can't wait. They can't be staged. We need to push them out when they occur. Now, this was actually potentially one of multiple updates that CrowdStrike makes on a daily basis. If you think about applications, if you think about your browser, you'll get multiple pushes to that a day, and you get the chance to accept those or reject or do them later. When we're talking about the stuff coming from a cybersecurity perspective, we obviously want to actually sort of push those down. So we pay for that service. We want them to be in there. So now let's consider sort of where this issue occurred. CrowdStrike reported that it happened in an update to channel file. Now, these are configuration files that contain the details of what to do if an incident occurs. And they're part of what we call a behavioral protection mechanism used by the Falcon sensor. So this update was specifically designed to target a newly observed maliciously named pipes, which are used sort of command and control frameworks in cyber attacks. So command and control is what it actually says it is. Take command of the remote machine and you take control of it from there.
The error manifested itself as the infamous Windows blue screen of death, as you said, which basically left the systems inoperable. How did this occur?
Let's go back to how the agent operates. It operates at a privilege level, and so therefore there has visibility across the entire operating system. Essentially, it functions as a certified driver on the system itself. It then uses these channel files, as I said, to update the behavioral patterns in order to identify and mitigate these potential cyber threats. According to CrowdStrike, it was one of these channel files that was updated, and when activating the device, resulted in this logic error. Now, what we mean by a logic error is an error in the program's code or the source code that leads to an anticipated erroneous behavior. And it's sort of classified as a type of runtime error that can cause a program to produce incorrect output or crash, as we saw in this case when it's running. Now, the logic errors themselves are not always easy to recognize because, unlike syntax errors, they're actually valid. So the code is actually valid when you actually look at it in plain language. But what it happens is it actually doesn't produce the intended behavior. So many systems actually sort of invoke what we call a self-preservation strategy. This isn't unique to these Windows environments. Sort of when they're faced with a situation that could cause irreparable damage or long-term damage. For example, if some malware can overload a system to such an extent that it could cause a CPU to overheat and actually sort of crash there. Now, we're not actually saying that's what happened here, but I'm just sort of showing a type of scenario that could occur, which is why they're going to self-preservation mode to sort of shut down. Now then, because the actual Falcon agent is installed and operates as what we call a boot start driver, the system was actually unable to come into the recovery process. So we go into self-preservation mode, an application would shut down if we're sort of sitting in that area there, and then we start to come up. But this is actually in that boot start driver, which means it starts at boot time. And it was obviously then it couldn't come to recovery mode. So we're stuck in this loop condition. And this is then we saw this blue screen of deaths that we saw all over the world. Point I'm making there is the systems weren't completely bricked. But what it meant was they would actually very likely require sort of manual intervention to actually be recovered.
Some initially thought that a Microsoft Azure outage that happened just before might be connected to this incident, though they ended up being unrelated. Tell us more about that.
So initially, responsibility for this widespread outage was actually thought to lie with Microsoft. And this is sort of a natural progression to make because the company, as I'll go into in a minute, had experienced an outage in the US central region sort of hours earlier. But also the affected systems which we're actually seeing across there was sort of around these Windows clients and Windows servers. So it's sort of a natural progression. We actually go back into that Azure outage we're talking about there. So they actually experienced issues, as you said, within the central US region there. Now, this was between 21:56 UTC on July the 18th and 12:15 UTC on July the 19th. These issues manifested themselves as customer failures with issues to the service management, the operations, and availability of certain services. What it appeared to be and what Microsoft reported it to be was it was a configuration change that impacted the connectivity of back-end services. Now, this was specifically to storage clusters and compute resources. So you can see we have this connectivity issue there, then we couldn't actually make the connection. So this triggered some automated mitigation. Some services were sort of started repeatedly as we tried to build up storage and spin up different areas, sort of come around with the fact we couldn't actually connect to it. So at one point, Azure, when they were trying to find the issue there, they recommended to customers to start actioning their disaster recovery plans. But then they were able to locate the cause down to this particular configuration change. They were able to roll it back and the services began to sort of see restored. It appeared to only impact customers with resources concentrated in central US. And this is essentially customers that had essentially a single domain sign-on to that particular availability zone. So if we actually sort of had a distributed environment there and it wasn't just this single sign-on, so we didn't have locks on the databases and that, then essentially they were sort of working. But then we saw services were impacted, which impacted things like Confluent, Elastic Cloud, and Microsoft 365. Again, sort of users that had that single sign-on to that availability zone.
What are some of the main takeaways from the CrowdStrike incident?
So there's many things that can actually sort of disrupt the service and applications and sort of massively impact our everyday life. You know, most digital services depend heavily on networks, web-based apps and cloud service. So that's the first thing we need to consider is we're living in this digital world. Anything comes across there. What the CrowdStrike related incident sort of serves as a reminder is that there are other factors in play too. We'll often think about this connected system and I talk about this mesh of an environment. You know, we're longer talking about this linear progression where we go client, network, application. There's this mesh where everything's sort of involved together. And what this tells us is that any one part of that can break or malfunction, and it can actually then sort of throw up this area. So really what you've got to start to do is to look at this service from the complete end. We start with the user experience, that digital experience. Can they actually access a system and then start to go back through there? If we look at that and sort of understand the anatomy of the outage, then we can actually start to use that to sort of make informed decisions about what to do next. Now, we know this CrowdStrike issue affected Windows systems with the CrowdStrike Falcon agent. If we then sort of tend to look, well, can we actually make a connectivity? Where's that commonality? So let's look at the network path to understand where the connection failures are. This gives us an indication specifically of what's happening. You know, if we started to see these servers where we couldn't actually get to the system itself, but I could get to where they were hosted. Because remember, this is impacting systems that are also running on VMs. So I could actually get to the hosting environment, but I couldn't actually access the system. If a service was running on a back-end system, I might have started to see some internal services. So they're all starting to give me these clues of what's happening around there. Now, the point I'm trying to make there is if we actually combine these signals together, you can actually start to isolate the source of the issue fairly rapidly. You can see what's going on. And once I do that, I can start to make decisions of what steps to take next. Now, I'll give you sort of the real life example, and this is a very minor one in the situation here. But basically, I discovered this was occurring. This occurred during Australian business hours or a Friday afternoon. And I was listening to a radio service over a streaming service there. It suddenly stopped. My first instance was it's a problem with the application or a problem with my device itself. I switched networks because I have the luxury of having two networks. Still no thing. I then switched systems. So I went onto my PC. I then started a test to see what was occurring. So it wasn't working at that point there.
Mike's test confirmed that the problem wasn't network related. Instead, the issue appeared to lie with the service itself.
So my mitigation in that place was actually, I went and got a manual radio out and just turned it on. And they actually told me then the studio was down, so they're actually going to sort of emergency broadcasting as it was. But the point was, I'd had that information, been able to put those signals together to understand what steps I needed to take. So the most important point of all of this, and the point I want to take away, is that there's a lot goes into a digital experience than you might actually realize. And as I said, it only takes one component or even just one function of that to fail or degrade to actually bring the entire service and delivery chain to a halt.
Now we're going to round up a couple more incidents that Mike has observed over the past few weeks, starting with Workday.
So on July the 6th, there was an issue with Workday where it impacted connectivity or availability of the system for around 3 hours. And sort of how this manifested itself was sort of just systems timing out. So you could get to the page itself, and when you actually went to log on, it would just simply time out. You couldn't go any further. So when you went to look at this, what it appeared to be was there's a failure with an authentication process. So I said you could get to the front page, you could actually load it, but when you actually went into that, the system itself was kind of cool. It actually recognized there was a failure. And then it sort of did a redirect. So it did a temporary redirect and it put to a static outage page. So it said, there's an outage going on. We're sort of working on it. So informing the users that was the problem there. Now, not only did this redirect time increase, but we also then saw this sort of a decrease in the SSL time. I say that because it's indicative of an authentication issue. And if you were to then look at the throughput, I said we're going to static page, we actually saw that drop as well. So all of these things indicated that the page itself wasn't actually loaded. So if we actually look into it, what we're seeing is that when we're making this request for it, that the URI, so the Universal Resource Indicator, the object itself, wasn't there. So it's actually saying, I recognize I can't get to that, and I'm going to go to this temporary page to sort of redirect it there. So really what I'm saying there is a problem in the back end. And the system itself was clever enough to be able to identify it couldn't reach that and redirect your temporary to this outage page.
Grammarly helps people like me eradicate typos in their copy. This month, the service has experienced 3 different disruptions.
Grammarly experienced several incidents, and these were spread across a number of days. Now, the latter 2 were described by Grammarly as service interruptions. And what we mean by that was they manifest themselves as functional failures. So you could sometimes log on, but essentially what it meant, I couldn't call the advanced features, so the AI types of features. So I could see sort of suggestions and corrections, but I couldn't make these alternate text change themselves. And we saw this in a number of ways. So you could actually sort of see there was a page load time increase because we're waiting to call these back-end services and sort of various other things around there. But again, all of this indicative of this back-end system itself. Now, if we come back to the July 13th incident, that was actually directly attributed to issues with Azure. And we know this because Azure themselves reported this, and we can actually sort of see this manifesting itself. This actually occurred when they made a change to update some configuration on their back-end systems. And what ended up happening was it sort of deleted an unused resource on there. Now, this resource contained other resources, and some of these were the OpenAI modules themselves. So these were unavailable. So if you're trying to make those calls at that particular time, you couldn't actually get to it. So again, a back-end system issue where we're trying to make that call. Another situation where you can get to the front door, but you therefore couldn't then access the application behind it.
Is diagnosing a fault with a service such as Grammarly more difficult because it's often built into other applications, such as a web browser plugin?
It's more complex and there's more interactions involved. So actually starting to go to a different third-party system and start to see that. But really, you can sort of do exception reporting and to understand. So yes, it's more complex, but I just need to be aware of all the moving parts that are involved in that. So the easiest way to do that, which is exactly what I did in this situation, again, this was a case where I was actually using the system at the time. I was able then to build a test that actually logged onto the system. So I'm testing at different levels. So first of all, I'm testing my authentication of the system. And first of all, I'm actually testing network reachability. Is it some issue from there? Right, I can get to it. Then I'm testing authentication. And then I'm making that call to that back-end service. It really is then quite simple to determine that's what it is. In that case, again, what's my workaround to that? Well, that's a service I'm looking on. I know where the fault domain lies. I just, in this case, need to wait to see what's happening.
So thanks for a deep dive into those outages, Mike. Now let's turn to the overall outage trends and what we've seen over the past couple of weeks.
There's a reversal in the recent downtrend. So we saw this downtrend as we're coming into that Northern Hemisphere summer period, that holiday period there. And now what we've seen is this upward trend as we've sort of come out from that. So from July 8th to 21st, global outages increased by 21%. Initially from July 8th to 14th, and then by further 2%. So only slightly, but again, this week we've seen this uptrend as well. So from July the 15th to the 21st. So we saw a similar pattern in the United States where outages increased by 52% from July 8th to 14th, and then by 12% from July 15th to 21. Now, in this 2-week period from July 8th to July 21st, there was 48% of network outages that occurred in the United States. Now, this is up from the last period we saw, where it was around 34%. So it's quite a sharp increase in the number of US-centric outages. And again, a return to what we saw for a large part of the year and a large part of the back end of the year, where the United States accounted for over 40% of all observed global outages.
So why do you think we've seen such an increase in US-centric outages?
So a couple of things. So we're coming off a reasonably low base. What I mean by that is the outage numbers that we saw, if we talk about the seasonal norms we see, they're relatively low to what we would see other times of the year. Now, we actually then saw that decrease coming in over the US holiday period. And now what we're seeing is this period when we come out of that US holiday period. So we've seen an increase in what we term sort of the maintenance, the engineering focus outages, whereas they wouldn't essentially been done over that period. And again, this is reflected in this return to the over 40% contribution.
So finally, Mike, was this recent uptick in outages related to CrowdStrike?
No, if we actually start to look into those outages, what we're actually looking at there is network outages, so interface outages themselves. So this is where interface has this 100% packet loss. If we think about how the CrowdStrike incident manifested itself, what we actually saw was it was at an application level. So we'd have seen inability to reach applications, inability to reach servers. So then the packet loss that we were seeing was at that egress, that edge of the network as it went into where those servers were hosted, where those Windows machines were actually hosted at that point. So that wouldn't have been reflected in the outage numbers itself because it wasn't a network outage.
That's it for this show. Please like and subscribe. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on X at @thousandeyes or send questions and feedback to internetreport@thousandeyes.com. Until next time, goodbye.